Hello everyone, I welcome you all for the Grand Innovation Day and I hope you are all enjoying this event, and it's going to get bigger with me joining the stage. I'm Harish representing EGS Computers India Private Limited. For the next 15 minutes, I'll be showcasing the new enhancements and new features inside SolidWorks simulation, flow simulation and plastics for the 2017 version. The motto of SolidWorks 2017 is the power you need to drive innovation, and it focuses on the topics like innovate, design, validate, collaborate, manage and build. And my prior focus is for the validation part. So inside validation, we have three kinds of products like SolidWorks simulation, flow simulation and plastics. SolidWorks is not only a 3D CAD design tool, but the user can also validate his products based on the product performance and qualities. So he can directly use multiple scenarios, make changes, and can directly come back and make how your designs is directly working in the real-time environment. So basically, SolidWorks simulation gives up a good set of enhancements on the three stages of the finite element analysis, that is the pre-processing, solving, and post-processing. So let's have a quick look on what are all the enhancements. The first one is the automatic decision making, where a small solver prompt will be dismissed here, and the user can directly see the errors or the prompts which the solver gives us. The next one is the stress hotspot diagnostics, where the user can visually interpret with the stress hotspots which is occurring on his product designs and see where are all the stress concentration or the stress singularities is happening on his product designs. We have some of the enhancements inside the post-processing also. Like we have the SolidWorks simulation basically gives us a beautiful color plots with the analytical values. So this time here in 2017, the maximum values which is exceeding the yield strength, the user can directly set some of the colors like which is being displayed inside the slide here, like pink color, or he can directly swatch up with the maximum or the minimum values. Say for this, I'm just displaying more than 7 megapascal, I'm including a value of a color like pink color. Then inside the 2017, we have an enhancement to copy a static study to a nonlinear or dynamic. It's a similar kind of thing where we do for the source to the target. And those of you who are using the SolidWorks version here, that is PhotoView 360, a new display has been introduced for simulation also. You can display your simulation results for your assemblies. So I'll quickly jump into the SolidWorks interface. So I'm using the same Myomo data set basically. So I'll access the simulation here. So SolidWorks simulation can perform any kind of complex analysis basically. If you access the static study, you can calculate the strength of your parts, that is outputs will be in the stress, displacement or the strains. You can study the heat expansion using the thermal study. You can do vibration analysis like frequency, buckling load factor, and you can study the impacts on your designs using the drop test. And you can calculate your life cycle of your product using the fatigue study. You can optimize your designs, and you can study the tensile and the compression properties of your materials using the nonlinear also. And in extensive, we have the dynamic studies to do your seismic analysis. You can study the response. You can do harmonics and modal analysis. So quickly, I'll access a small static study which has been predefined. So inside the 2017 update here, the user can calculate the mass properties in the initial stages here. So you can simply toggle down the unit systems. So the components which is being listed out inside the study will carry out all the informations related to the mass here. So when you are converting your finite element model, we'll basically eliminate some of the masses like small fillets or the small holes. So we can directly predict how much mass we are eliminating for the conversion of the study. So simply I'm just opening this small battery part cover. We have some of the enhancements inside the options of the simulation basically. So those of you who are using the structural members here, structural beams to simulate, we have a new enhancement that is automatically update beam joints when it has been activated. So when you are accessing the structural beams, when you are going to modify some of the dimensions or edit some of the features, previously we need to recalculate all these studies, all the valid joints basically, and also when you are using some of the split lines or split geometries, that will take some time to update also. So in the 2017 version we have the automatic updates, and those of you who are accessing the dynamic studies, basically it will consume more amount of disk space in the previous versions, and also when you are loading the geometry file, again it will take some of the time. So in 2017 version we have some of the improvements, improved performance for the dynamic plot updates also. So this is what I was just talking about, that we have the automatic decision solver. So as a user I'm just giving it as a 5 seconds basically, and I'll access a small static study. So this is basically a small plastic component here. So I'm accessing the default material database which is available. So this material database contains of a number of material classifications like steel, iron, aluminum. So once I access any of the classifications, it is being differentiated with different grades along with its mechanical properties. So for this I'm simply assigning it as an ABS plastic material. So based on the real-time condition I'm constraining my degrees of freedom here. So I'm just fixing this particular edge here, and for time constraint I'm using the symmetry, that is a quarter symmetry of the model. So I'm just since all this entire part is going to exhibit the same kind of loading conditions, I'm using the symmetry constraint by selecting these reference phases. And the next thing is this phase will exhibit some translation movement along the x direction basically. So I'm just providing a translation movement by selecting this phase, and I'm assigning it as 2.3 mm, that is a translation moment here. So simply I'm just going to run this small study. So this is a solver message which will be prompted here. So in the identification stage of your problems, you can basically use this kind of solvers, and the next day when you just come and review this particular study, you will have a small prompt of this error message also. It will say what is the error which is being calculated. Right now it says that I am exhibiting large displacement problem because I am using a static study to do a plastic material. So let's just quickly review the results here. So this plastic material will have the yield value of 34. Right now it has got exceeded to 65 megapascal. And it will have the displacement here like 3.6 mm basically. So for the translation moment which we have provided, this is going to exhibit around 3.6 mm. So in the 2017 we have a new tool, that is the stress hotspot diagnostics. It is going to work in the similar fashion of how we mesh the model like coarse to fine. So we need to just imply the sensitivity factor here, and I'm just going to run this hotspots. So it will just give me a prompt, sorry. So it is just going to give me a small prompt like how the stress hotspots has been detected in the model. So as I told before, in the 2017 version you can simply copy a static study to nonlinear dynamic or linear dynamic. So this is going to copy all your, transfer all your boundary conditions including the mechanical properties also to one source study to the other. If you are using configuration based studies also, you can simply copy this. So for time constraint, I've just used this nonlinear study here. That is the results here. I'm using the similar boundary condition. So let's have a quick look at the stress plot. So right now you see that this is a little bit equivalent to the yield value, that is a 34 megapascal. It has got it. Let's have a look at which position the maximum stress is acting. So it is in these particular areas here. So I have a new option in the probing also. So if you are going to convert your model and if you know the node numbers for your particular geometry, you can simply type any of the node numbers here. Right now I'm just typing it as 250. And once you just give OK, So at that particular node number, you will have the value of the von Mises stress plot, and that is going to indicate along with the x, y, and z directions. And when I just go to the at location, and I'm right now my stress concentration in these particular phases alone. So randomly I'm just going to select some of the nodes here from my model. So in the 2017 version, we have an option to capture this as an image also. This will be saved in the JPEG, bitmap or PNG file formats. So you can use it for your documentation of your reports also. So from the predefined node numbers, we can directly calculate their response here for all the node numbers. So right now I have the two similar studies which is run here. So I use the option to compare my results. So I'm randomly selecting the study result plots. So these are for the linear results, and these are for the nonlinear result plots. So my window will be tiled up into 4 basically. So right now I'm accessing one of the view from the tiled windows. So I have two other options in comparison of the results. Basically, one is the synchronizing view and other one is the capture image. So once I just click in the synchronizing of any views, so if I'm going to rotate or zoom any of the models here, I can simply see the changes in the other windows also. So this can also be saved in the file formats like PNG, JPEG or bitmap. So I'll just come back to the slide again. So when you are setting up a large problem and you are assigning large number of contacts, say it is a bonded or a no penetration, the user has an option to edit multiple contacts by selecting all the contacts and just assign it as a no penetration or bonded. So this is going to save a huge amount of time. And as I said, we have some of the post-processing results in dynamics also, like the nodal von Mises will directly review the results, and only the nodal von Mises stress plot will be shown in the faster manner. Then we have focusing on the nonlinear, we have 3 control methods, that is the force control, displacement and arc control. So in the 2017 version, we have an arc control method to focus about the accuracy of the results. And this is one such good enhancements, that is the offloading of the simulation results. So you can directly offload your simulation results from one system to the other. Basically can perform the pre-processing and the solving in the workstation, and you can simply use these results for the presentation purposes. And the beams will exhibit the remote loads and masses in the 2017 version. So I'll quickly move to the next product, that is a flow simulation, basically to solve all your CFD related problems. So this is going to do the problems related to the fluid flow or the heat transfer analysis. So you can simulate the exact flows across your internet designs. And moving to the next product is basically the SolidWorks plastics, which is very much helpful for the organization into the injection molding setup basically. So the user can directly see the simulation of the melted plastic flows, and you can directly visualize how the plastic is going to flow inside the molds basically. So I'm having a small example of this. I'll go to the interface. So again, this is a small plastic part, that is the enclosure cover. I have a small predefined study basically. So this is going to exhibit the cooling lines. The plastic melt flow will be along these channels basically. So using the small SolidWorks sketches, I am just sketching some of the lines saying that the flow is going to take place along this particular direction alone. So for this, we have a vast material database again. So it contains more than 4,000 plus of materials, and this is being classified with the manufacturers again. So if I access any kind of ABS, it has more than say it is more than 500 plus of materials along with its plastic mechanical properties. So for this I am assigning an ABS plastics, and the fill setting is very much simple for me, that is 230 of the injection pressure, 100, and I am just designing a cooling line for this. Let's have a quick look of the results. So since all these things are integrated within the CAD system, you can switch over to one analysis to the design interface and make some of the modifications. So right now for this particular result plots here, I have a fill time of 1.2 seconds basically. So this will directly animate it. So you can see the flow taking place along your plastic melted part. So I'll be having the information of air traps, weld lines, so it will show the weld line locations also. So you can virtually test your plastic parts inside the SolidWorks interface. So I'll come back to the slide again. So that is my end of my presentation here. So we have the stalls at the end. You can directly visit us, and if you have any queries, you can kindly contact me. So thank you all and listening to the patient. Thank you.